This is Solve It for Kids.
Hello, my amazing and curious friends. My name is Jennifer, the Dean of all things STEM and STEAM, and this is Solve It for Kids, the podcast that gives kids and families a peek inside the real world of scientists, engineers, and experts as they solve problems in their jobs using creativity, cooperation, and critical thinking. And now please welcome to the show my podcast partner, Galactic Space Geek, Jeff Gagne.
Hello, Jennifer, and hello, listeners. Wow, do we have a fun episode for you today, because we are talking to a scientist that touches two separate areas that have lots of overlap.
Oh, this is going to be so much fun. What problem are we solving today?
Where could we find life in the solar system?
Where could we find life in the solar system? Oh my goodness, I can't wait for this conversation. Who is our guest today, Jeff?
Our guest today is the wonderful Natasha Carr. She likes to describe herself as being right in the middle of the Venn diagram between a planetary scientist and an instrumentation physicist.
Welcome to the show, Natasha.
Hello, hi.
We are so excited to have you. And I like to ask the first question, but I actually want you to explain first, what is an instrumentation physicist? What do you do with that?
Yeah, so it's a little bit of physics, a little bit of engineering, and a lot of in between. And so we design, we develop, we test, we break a lot of different types of instrumentation, which can be used for all sorts of different things. But personally, I work on space science and planetary physics. So my instrumentation will be going to different planets in the solar system.
Oh, that's very cool. So as a kid, did you always want to do stuff like this? Were you the one staring up at space and wondering what it would be like to be there or meet other beings from other planets?
Oh, most definitely. I think I was 3 years old when I said I wanted to be an astronaut, and now I'm almost 23 years old, and I'm still wanting to do that sort of thing. Yeah. Well, yeah, when I was 3, that was the main focus. I had a telescope. I was into all watched all the type of science shows and that sort of thing. And then when I was about 6 or 7, I realized that space was really dangerous.
Yes.
That was scary.
Good thing to learn.
Yeah. And so then my sights set on physics and on space science and what I do now. So it's been a pretty straightforward path for me. You know, a lot of incredible icons that I've always looked up to surrounding me. And then I'm now working with them, which is really cool.
Right? That's awesome.
Really cool.
Yeah.
And I bet if they're not already, very soon, they're going to be saying to other people, I work with Natasha.
I mean, I hope so. Definitely.
So I want to jump right in so we can eventually get to our main question. What is instrumentation physics?
Yeah, so it's looking at what scientists want to do, what engineers can build, and then developing the in-between bit. So people who might be geologists, chemists, biologists, anyone who's interested in asking questions about planets, and then turning towards engineers and saying, what do we have here and how can we make it better? Because we're the people that develop those ideas and make them become a reality. And then we build it and launch it.
That's fantastic.
Okay.
Yeah. So
that sounds very straightforward.
Well, there's quite a lot of wiggling in between. But, you know,
right. There are just a few things you have to figure out about how to create something to launch into space and make it work, right?
Mm-hmm. Yes. Everything from temperature to how much it's going to be shaken when it's launched,
right,
to how we can communicate with it and whether it might work in certain environments. Because even just the solar system, it's a tiny part of space, has so many incredibly dangerous environments to withstand.
Yes.
And our instruments can only withstand so much of it. So it's everything from it being destroyed to it working fine is how we have to think.
Okay.
Exactly. And then also once it gets out there, you don't really have a whole lot of control over what it does or if something goes wrong, correct?
Not particularly. For example, my team worked on the Bepi Colombo mission, which is currently on its way to Mercury. And we don't know when it gets there, when we turn it on, if it's going to do the job that it's designed to do.
Hope so, fingers crossed.
But yeah, there's always that gamble, and it's been traveling since 2018. So it's always that big hold your breath moment and cross everything that you can possibly cross to hope when it turns on, it shows us what we expect. Yeah.
Wow.
Very scary stuff.
Until then, there's really nothing sort of like it is officially off, or I've always kind of wondered in that safe mode that we usually hear NASA talk about or space scientists talking about, is the spacecraft sending anything like even a beep once a week to just say, hey, I'm out here? Or is there nothing until it's turn on time?
Yeah, it honestly depends on the type of instrumentation that you've got on there, what mission it is. How each mission varies quite wildly. I'll come back to Bepi. So a few months ago, it did its first Mercury flyby. So we turned on one of the cameras and it took some pictures, and we've got those back now. So we know that camera's working.
Yay.
But a lot of the other instrumentation, like the more complicated instrumentation that isn't a camera that you would possibly find here on Earth, is a little bit more complicated. And also you've got to think about the power needed to do that. A lot of the time, one of the massive restrictions is power. And so you've got to be able to serve that for when you definitely need it, when you get to your destination.
Sure.
Yeah, exactly. So also, you and I have been talking too. You're also interested in astrobiology. Can you tell everybody a little bit about what that is too?
Yeah, definitely. So astrobiology is a study of the origin, the evolution of life out in space. So anywhere that isn't Earth, really. And it's a really interesting subsection of science because as physicists, we can study it. As biologists can study it. Chemists often get really involved, geologists. So it's a really nice culmination of loads of different STEM subjects. And we can always evolve with that. And also, who doesn't want to find aliens, right?
Exactly, I do. I think it'd be interesting, yes.
And this is just the science behind it. And often people think, oh, well, it's going to be really difficult. But actually, it's not always just about finding life itself. It's about finding habitable conditions.
Right.
That's a little bit more possible with the instruments that we use.
Okay.
That's cool.
So with the instruments that you use, I kind of wondered, why don't all spacecraft include some sort of instrument that is searching for life? So
that's where it gets a little bit more complicated, because even with the missions that you look at now, like Perseverance, like Curiosity, that are on Mars currently, they aren't looking for life itself. They're looking for signs. They're looking for puzzle pieces that lead us to look for life. So, for example, the rover that will be launched soon for the European Space Agency, the Rosalind Franklin rover, that's part of the ExoMars mission, that itself will be looking for the life itself. So instrumentation that is able to look for life itself is a little bit more complicated because it needs to not destroy it. And a lot of instrumentation that we use now, if you use that instrumentation, it inadvertently kills the life that could be in the sample that you take.
Oops. I mean,
that would be bad.
Exactly.
I mean, but think about that for a minute. That's not something that most of us who aren't physicists think about, right? You're just like, oh, well, you find life and there it is. And but you don't think that the actual instrumentation that you're using might, I don't know, kill the life that you're looking for. That's intriguing. Can you give an example of that? Is it because of the heat? What would do that?
There's a few different types of spectroscopy which are used to look at chemical compositions that actually are quite destructive. So there's things like laser-induced breakdown spectroscopy, or LIBS, and that uses a laser to physically pummel away at a sample, and that isn't great for life. Sometimes,
no. For us either, for us humans either, I'm guessing.
Things like UV is often used, which again, isn't great. We don't like UV, we get sunburn from UV. So smaller microbes get completely destroyed. X-rays as well are sometimes used, which again, as we know, aren't great for us. So why would they be good for anything else?
Right.
So yeah, honestly, it's about the scientific trade-off. So you have the geologists and the chemists saying, we need this type of instrumentation, so please send this. And that's a little bit more important for the questions that we're asking for this mission. Right. And then we have missions like ExoMars, where their sole purpose, or one of their sole purposes, is to look for evidence of life. Yeah, so it depends.
Wow.
And it depends on who wins the argument as to what goes on the mission.
Okay.
Exactly.
So I'm hearing that the instrumentation that goes on each mission is A, very individual on what that mission is meant to be, but B, also very specific.
Mm-hmm.
Yeah.
Is that because of how hard it is to do the science to get accurate information? Or is it more, it's difficult just because this stuff is going really, really far away, so we need it to only do this one thing?
So a little bit of both, I think.
When
you're choosing the instrumentation, you've got to think of so many different things. And this is what we call a trade-off or a payoff. And so a lot of instrumentation scientists and mission specialists, they will almost have this pro-con list of each different type of instrumentation, depending on what that mission is for. Often you'll have very specific questions in your scientific question bank. And if that question can only be answered by a certain type of instrumentation, you have to send that instrumentation. You have to send that very specific package. Whilst there are other things that are a bit more broad and that can be broadened. So things like cameras will always be quite broad, because we can have a look at environment, we can have a look at atmosphere, we can have a look at what the terrain looks like, all that sort of thing by having a camera on board. While if you have something more specific, then you're starting to squeeze into those really specific questions.
Yeah.
It also depends on things like weight, because you can't always something huge and bulky onto a mission. You have to think about how fragile it is, what the type of radiation environment you have to send it through. So things like Jupiter, which is my speciality, the Jupiter environment, it's highly, the radiation is massive. So we have to make instruments something called radiation hard, which means that they won't be destroyed by the radiation that we encounter out there.
Sounds important.
Yeah. Just kind of. Okay, so all of this talk about instrumentation is so cool, and kind of leads us into the question, where could we find life in the solar system? Are there people that are studying it and saying, okay, we think here or we think here, and then are they going to try and design experiments to go find it there, possibly?
Definitely. Yeah, so there's one of the big groups is Mars. So we've already talked about Perseverance, Curiosity, all the rovers that are out there in the future, which is ExoMars, and actually bringing back samples from Mars to have a look at here on Earth.
Wow.
Because we can do a lot more experimentation with a lot fancier equipment here on Earth than we can if we send it to space. And then we have the other side, which is actually the outer solar system planets. So that includes Jupiter and the Galilean moons. So the 4 moons that Galileo saw hundreds of years ago when he used his telescopes. Those 4 moons, little did he know, are actually really great candidates for our search for biology and the search for life elsewhere. And the big one, which is currently behind me, not that you guys can see that, but Europa is a huge candidate there as well. And also Titan, which is one of Saturn's moons, and even possibly further out. There's a lot of potential, and there's a lot of groups looking at where we could possibly find life.
Wow. I think that's so cool and a little mind-boggling.
Yes.
Yes, agreed. Now, I need to jump in. Jupiter and the whole system, my favorite planet.
Yeah.
And I'm a huge Europa fan. Very excited about the Europa Clipper coming and missions beyond that. Can you sort of explain to our listeners what it is that you are doing? Did you work on instrumentation for the Europa Clipper? Are you working on future missions, maybe both?
During my undergraduate, which was the last couple of years, I worked on projects to do with actually the proposed Europa lander. So a very specific type of spectroscopy called Raman spectroscopy, where we use lasers to characterize the chemical composition of a sample.
Right.
So that was the type of instrumentation I was looking at for those 2 years. And now I've moved on to X-ray instrumentation, which is super interesting. It's very novel. And we're looking at possible missions in the future that would be to do with not just the moons themselves, but the whole Jovian system.
Wow.
And how each moon interacts with one another, the whole chemical composition of surfaces, the magnetospheric environment, just the whole Jupiter system, because it's so interesting and there's so many
that
we have. So
it is, yeah.
It's crazy.
Okay, so you're going to gather this information. But what I've always been curious about is, a lot of people say when we look for life that, okay, we're looking for more humans. Well, that's not necessarily true. So when you consider evidence of life that you would like to investigate further, have we found any, or are we still just looking, or
we're
guessing?
Still pretty much just looking, and we now have a little bit more of a clear path. Because we now look for 3 very specific things when it comes to habitability and the signs of life. And that includes 3 very simple things, really, because you'd expect it to be things like, really specific molecules or food or
yeah.
Sure.
It's water. Water's the last one. We look for water.
Okay.
We look for the proper chemistry, and that is 6 elements that are carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. 6 very, very kind of simple elements.
Right.
And also energy. So we need to look for a source of energy for this life to thrive off of, whether that be light. It's different for every place that we look. So those are the 3 main things we look for: water, energy, and chemistry.
Okay. So Europa, icy moon, liquid water ocean underneath, water, check.
Yeah, exactly.
We are going to, and we probably already know which chemicals are on Europa because we've had orbiters around Jupiter for a long time now.
Right, yeah.
What would the energy be for Europa specifically?
So, Europa is very close to Jupiter, and when it orbits Jupiter, it actually gets squashed and stretched. It tidally heats. It's called tidal heating.
Okay.
Io is actually the biggest example of this. So Io, in one orbit around Jupiter, it changes in diameter. By about 100 meters.
Wow.
Oh my gosh.
Stretches by a lot. Europa's a little bit less than that, but it still has quite a lot of tidal heating. But also we think that possibly radiation could be delivering energy to the surface. But that could be slightly too much energy and the wrong type of energy. It's still a possibility. So the tidal heating and the radiation environment are the 2 energy sources that we see out there.
Wow. I did not know that they constricted and, expanded. Wow. So could you explain what is Europa Clipper supposed to do then?
So Europa Clipper will actually be out there at the same time as another orbiter, which is JUICE. JUICE is on its way currently. Europa Clipper will be joining it next year on its way. And so they're going to be the first 2 missions to be out at the Jovian system at the same time.
Wow.
We have a doubly sized lab out at the Jovian system. So they're going to be talking to each other a lot, and they're going to be discussing the science that they're doing together. Europa Clipper focusing solely on Europa, so that will be orbiting Europa, looking at its surface, at the atmosphere that's possibly around there, possibly the magnetic field that is produced in Europa. So it'll be focusing solely on Europa. Whilst JUICE is doing a little bit of everything, looking at Ganymede as well, which is another one of the moons that we are interested in.
Wow.
And how each moon fits into the system as a whole and how they could possibly be linked to one another. Because we know that the 4 Jovian moons, especially the 3 inner ones, which are Io, Europa, and Ganymede, they have relationships with one another that mean that they sometimes share chemistry. And they sometimes, so they influence one another when it comes to the chemical environment and the magnetospheric environment and the particles that they share. So it's really interesting to have 2 different missions out there that can talk to one another and perform science together.
Well, yeah. I mean, think about all of the information that we are going to get from that as those 2, wow.
Yes. And it's also a really massive international collaboration. So NASA is Europa Clipper, but we've also got the European Space Agency with JUICE. So it's a huge cohort of people working on really cool science, which is something that I really enjoy about planetary.
That's fantastic.
It brings together so many people.
Yes.
It sure does. And the Jupiter system just has so much involved. All 4 of the Galilean moons are very different from each other, each of them being very different from the main planet itself. So are you expecting, now that you're working with X-ray instrumentation, are you expecting between the Europa Clipper and JUICE to be getting information that's going to sort of lead you in a direction of what X-ray instrumentation may come in your future to start building for new missions?
I think for sure. I mean, we're already seeing it with the Juno mission as well. So Juno's been out there for a couple of years, and we're getting data back, and it's very specific data. So it's not just about the whole system; it's about specific moons, specific parts of its orbit.
Okay.
And we're looking at using data from Juno when we can to influence how we might test our instruments down here on Earth. And at the University of Leicester, we have the facilities to be able to test the instrumentation and also the science in a lab environment. We're using the proper data taken from missions and simulating that in a lab so that then we know how these things might interact with our instrumentation and with one another and what we might expect to see. So that's always really exciting. We're taking real data.
Sounds cool.
So that's always exciting. Yeah.
Yeah. I mean, I think this is really intriguing. And, could you explain kind of how long it takes to get there and how long these missions last too? Because I'm not sure people understand that it's going to launch and take, I don't know, a couple of years to get out there. And then this mission could last, I don't know, 6, 8, however many years.
Yeah. So again, depending on the mission, I can speak for Bepi as that's what my team works a lot on.
Right.
The original, thought of Bepi was in the early 80s.
Wow.
Wow.
The kind of mind child of Bepi was created in the early 80s, and it launched in 2018. And it's not there yet. So it's the career of someone.
Yes.
So it's that really long process, not just to get there, but to actually get a mission into real life and into planning is a long time. Getting it through the planning is a really long time. And then actually getting it onto a launch pad and launching it, it's then at least, it can be 6, 7 years until it gets into its destination, depending on where it's going. Yeah.
Right. That's crazy.
Okay. So with the Jovian system and everything that's going on out there right now, there's so much. The James Webb Space Telescope, there's an infrared image of Jupiter that a lot of folks have seen out there of the main body planet itself.
Yes.
And scientists just announced that there is a much more powerful jet stream going across the equator of Jupiter right now. And this is stuff we are just learning about a planet we've been looking at since Galileo. Is information from the Webb telescope also going to factor into what is happening now and your future missions on that search for life in the area?
I mean, anything and everything can affect that. If we're getting data that is useful and interesting from James Webb, even from the telescopes here on Earth, like the Keck Observatory, it can influence how the scientific questions are changed of a mission. When we propose missions, we can use it as evidence as to why we need to go there. And so the big X-ray telescopes for us are really interesting as well. So Chandra and XMM Newton are 2 huge telescopes that look out into the universe, but also within our solar system and looking at X-rays and where they're being emitted from. And so we use these as almost evidence to say, right, we've seen this, we need to go there now. That's definitely what we need to do.
That's fantastic.
It is a progression for sure.
Yeah. So I want to go a little sideways here and ask you a different question. So if there is a young listener that we have out now or whatever, how would they get to do the cool stuff you're doing? What would you recommend kind of their path be or get to do all of this? Because first of all, I'd like to go back to school and do this.
Definitely.
But what are your suggestions for our young listeners?
I think working as hard as you can at school making sure that you take every opportunity that you can to learn about science and talk about science. If there's a teacher that is really interested in science, talk to them, because they'll be really, really interested to hear what you want to say. And we'll always listen to your thoughts and answer your questions, because that's what they're there for.
Right.
Also keep curious, keep asking those questions. And if someone says, oh, I'm not really sure, then read books. You have, there's incredible people out there on YouTube and things like that you can go straight to, whether that is Bill Nye or it's us on this podcast.
There you go.
You have such a plethora of people and engaging videos and books and anything you could think of now. So read and listen. And also just keep excited about it.
Yes.
It is exciting.
Yes, it is.
Going to these planets within, hopefully, my lifetime, our lifetime, and your lifetime listening, will be setting foot on the moon again. Maybe even Mars. That's what I'm hoping anyway. It's the best time to get into this because we have so much interest and investment in this.
Yes. Yes.
Wonderful.
Exciting.
So most of our time so far has been talking about what you have done and are doing right now and what you'll be working on for the future. With all of the info, and we did talk about how new information will change things and you never know exactly, 5 years from now, 3 years from now, what an instrument you might be building will be. As of right now, with all the information you have about the Jovian system, let's go back to that because you're working on Europa right now. If you could build any instrument you wanted to send out, and Elon Musk would just be like, you know what, Natasha, throw it on my rocket. I'll send it out there for you. What would you build to send out to the Jovian system?
Good question.
I think it would have to be something with a couple of different modules to it.
Okay.
Okay.
Explain a little bit, please.
So I'm going to go with some sort of lander for each of the inner moons. So Europa, Io, and Ganymede. Because there's nothing better than landing and being able to dig things up and test them with lots of instrumentation from spectroscopy all the way through to Raman and XRF and the more complicated stuff and cameras. And then I would also have a couple of different satellites. Big old polar orbits around each of them to map the whole surface using X-ray, because that is what I work on, so I've got to get a job out of it.
You're allowed to be biased to that. It's okay.
I think it would have to be that sort of mix of satellites and landers so that we could get a big picture and also a really specific picture. Because
that sounds fantastic.
We often get the chance to land and orbit all at the same time. We only really do that on Mars. So
I think that would be great. Now you just have to design it. It has to not be too heavy and you have to pay for it. So no biggie, right? But
if anyone is out there and wants to
there you go. Anybody want to collaborate with Natasha? There you go. That would be fabulous. Oh my gosh, this has been so fun. But now we are at the time in our show where we ask our guests to give our listeners a challenge. I'm very curious.
Oh, this is going to be good.
Challenge is going to be, Natasha.
Well, now, I think after my opinion has been said, it has to be now, what type of instrument or mission would you design to try and find life in our solar system? And where would you send it?
Oh, I like that add-on.
Yeah. About Jupiter and the moons. We've talked a little bit about Mars. We haven't even touched on Venus or Mercury or Saturn and Titan out there. So you tell me. I want to know where it's going and I want to know what it's going to do when it gets there.
I like it.
I love that. I think that would be fantastic. And, the thing is NASA, I know at least, is open to some of these challenges and all this kind of stuff. And they're curious. So if you come up with a really good one, maybe you send it off to NASA and say, this is my idea. You never know. These things take, 30 years to plan by that time? The
Solve It satellite. You've heard it here first.
There you go. The Solve for Kids satellite. We would take that, wouldn't we, Jeff?
I think we would. I think that'd be all right.
I think that would be fantastic.
That would be good. I love Natasha's idea of a satellite that's got several different things.
Exactly.
If Elon can send up a single stick that's got 60 Starlink satellites that just go ding, 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 and why can't one spacecraft? I mean, heck, Bepi Colombo is 2 spacecraft that are going to separate when they get to Mercury.
Well, this has been so fantastic. Thank you so much for being on Solve for Kids, Natasha.
Thank you, Natasha.
Thank you very much. Thank you.
What a fun episode. And my goodness, how long could we talk about where we might be finding life out in the solar system? And being a space geek right now is an absolutely awesome time because we have the science, engineering, and capability and wonderful people like Natasha working on these problems so that we can follow these missions to so many different places.
Oh, yeah. I mean, now is the time that we've kind of all been waiting for, right? Like you and I kind of grew up on hearing about little green men, which, by the way, there aren't any, right? But how cool to be able to have all of this physics and these instruments that we can learn if there's life on other planets or if there could be life on other planets. I mean, this is just mind-blowing to me. What do you think, Jeff?
Oh, completely. And the fact that we're doing it out in the solar system at Mars, and we're about to send the Europa Clipper that Jennifer, you and I were lucky enough to get to see.
We did. We saw that.
To Jupiter's moon Europa, and then Saturn has a moon, Enceladus.
Yeah.
So many different places, and lots of us that are space geeks have thought about life out in the solar system and where it may be. And a lot of kids have even done activities of, okay, what do you think that alien life would look like?
Yeah.
And where might you find it?
Exactly.
I love Natasha's challenge for us to add what type of instrument would you design and where would you send it? What a great addition to get people thinking deeper about the science behind this.
Oh, exactly. I think this is so fun. I mean, don't get me wrong. We'd love to see pictures of different things that you think an alien might look like or just life on other worlds. But even digging deeper and going to the instrumentation, that is so cool. So if you have an idea for that, please let us know. Tag us on social media. We are at KidSolve at Facebook, X, and Instagram. And you can also check out our website, solveitforkids.com, and send us emails through there. We're going to have information about Natasha and also some books that maybe you want to read to learn a little bit more about the search for life and about the instruments and the probes and all of the different things that NASA is already sending out there.
Absolutely. And if you're starting with a blank slate and you don't have ideas right away, go look up NASA's Perseverance Mars rover or the Europa Clipper, and you will start getting some ideas to design your own. Until next time, you'll hear Jen and Jeff on
Solve It for Kids.